All right, so today I want to talk about different kinds of bases and things. But first, what I want to talk about was to kind of compare it with music and mathematics. Many do know this, but many don't know that there's a lot of math and pattern in music. For instance, if we were looking at a score like this and everything, this would be a 4/4 times table, meaning that each of these quarter notes would be one note in a frame that's 4 notes long. So obviously, if we try to read this music, it would do something like this, where 1, 2, 3, 4, 1, 2, 3, 4, and then it would repeat. So that would be 4 notes in one frame. Now, if we kind of change a little bit, we'd have 3 to 4, and that means 3 notes in one frame. It'd go 1, 2, 3, 1, 2, 3, 1, 2, 3. So after 3 notes, that would be the end. Then we do this in 2/4, which would be 1, 2, 1, 2, 1, 2. So 2 notes per frame. So the way we can think about this is in mathematics is that it's a pattern of 1, 2, 3, 4 versus 1, 2, 3 versus 1, 2. Now, in math, we have this thing called base 10. That's our normal base system to adding and subtracting. Typically, what that means is that we have these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. After we hit 9, it kind of goes back to 0, which is 10, 11, 12, 13, 14, back to 0, etc., etc. Now, we can actually do this in different bases as well. For instance, base 5. Base 5 means that there's only 5 numbers. We would just have 0, 1, 2, 3, 4, then go back to 0. So for instance, if I had something like the number 8, I could count this and go 1, 2, 3, 4, then I have to skip back 5, 6, 7, 8. So 8 in base 5 is actually equal to 3. So it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, back to 3. Now, let's look at base 3, where there's only 3 numbers. We'd have 0, 1, and 2. So 0, 1, 2, skip back to 0. So 8 in this case would kind of skip back as we go 1, 2, 3, 4, 5, 6, 7, 8, which would go to about 2. So that's how these work in these different bases. It's also known as modelu. If I pronounce that correctly, it's this idea about having different numbers in different bases. So, and that's the way I remember using it, also known as mod form. Now, going further, let's look at our standard form and how we actually add numbers. For instance, if we look at a number like this, like 1458 plus 285, this is in base 10 where we use the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all of our standard numbers. So to do that, we would add 8 and 5 together, which is 13. But we can't put 13 into one section where an individual number would go, so we'd put the 1 here and add the 10th place on top, right? Then we'd add this number 1 plus 5 plus 8, which would be 6 plus 8, which is 14, and we have 4, and put the 1 on top, because this would be our 14. Then we combine this 1 with 4 and 2, which would be 5, 6, 7, 7, and we drop down the 1, and we get that number. Now, in a different base form, let's say base 6. When base 6 happens, that means that we're kind of based on using these numbers, the base of 0, 1, 2, 3, 4, 5. So for instance, if we add 3 and 5 together, 3 and 5 gives us an 8. Well, 8 is not part of our base set. So if you want to think about it in a different way, we can think about it as counting it up. For instance, if we have 8, I go 1, 2, 3, 4, 5, 6, 7, 8. I'll land at that 2. So in a way, 8 is essentially 12. I drop this 2 down and put this 1 here. Then I would add these. 1 plus 5 plus 3 would be 9. 9, once again, is not a number, so we'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. It'd be 13. We put a 3 and a 1. So then we take 1 plus 4 is 5, plus 2 is 7. 7, once again, isn't here, so it'd be 5, 6, 7. It would be 1 and 1. We drop this down and get 2. So this would be in base 6. Continuing forward, here's a different situation where we're subtracting. Well, for subtracting in base 10, it's very simple. We use our numbers 0 through 9 again. In this case, though, 2 minus 3, that gives us a negative number. And 2 is not large enough to help us in this situation. So what we would do is we actually would try to steal the number from the one in front of it, turning this into a 9. This would actually have to be stolen to turn this into a 2. This becomes a 12. So then we'd have 12 minus 3, which would be 9. 9 minus 1, which would be 8. And 2 minus nothing would be 2. So we'd have 289. Now, let's try this in a base of 3 instead, where base 4, we'd only have 4 numbers. So once again, I can't subtract 2 from 3. This would give us a negative number. So I would have to steal this one. And because this is 0, I can't steal from this, so I'd have to steal from here. If I steal from this one, this drops this 3 into a 2. Now, a 10 in a 4 case here would be a 3, actually a 4. So what would happen is this would go down to a 3. This would then, instead of 2, we'd steal the 1 from here. So that's kind of like saying 4 plus 2, which is equal to 6. So this 2 then becomes a 6. So 6 minus 3 now would be 3. 3 minus 1 would be the 2, and 2 minus nothing would drop down to 2. And this would be base 4. Now, I want to show another method here too. Here's the one I like to call ones, tens, 100s, also known as expanded form. Now, expanded form, we kind of group up the numbers differently. Here it is in base 10, where once again we have our numbers 0 through 9 that we're allowed to use, and we'll just add these together. How this works is, first we're going to take the ones category here, which is a 7 and 6. This is the ones. We'll add these together. 7 plus 6 is 13. I place this in the ones. Then I'm going to take this 6 and 5, which are the tens. This is kind of like saying 60 plus 50. Well, 60 plus 50 is going to be 110. So it would be 110, and this would be our tens. Lastly, I'm going to take the hundreds, which is right here. We'll just say huns, right? And we'll put down here hundreds. Well, this is like saying 400 plus 800, which is actually going to be about 1,200, or 1,200. Then we can add these all together. Well, 3 plus 0 plus 0 is going to be 3. 1 plus 1 plus 0 will be 2. 1 plus 2 is 3, and we drop down the 1. And this would be your answer. Now, let's take a look at that when we have a base of 5. Base 5 being that we have 0, 1, 2, 3, and 4. So again, we're going to take our ones here. But if we take 3 and 2 together, that'll give us a 5. Well, a 5 would bring us back to 0, which would basically be like getting a 1. So what we're going to do is put a 10 here. So this is our ones. Then we're going to do the same thing with our tens. Here's our tens. 3 plus 4 is actually 7. But in this base system, we don't have a 7. If you want to, you can always count it. 1, 2, 3, 4, 5, 6, 7. That'll give us about a 12. So, or a 120 in this case. Lastly, we're going to do that hundreds. Well, 2 plus 4 is 6. Again, it's a legal number in our base system of 5. So we can count it. 1, 2, 3, 4, 5, 6, which is about 11. Or in this case, it would be 1,100. We could add these together, and we get 0 plus 0, 0, and 0. 1, 2, 0 would be 30. And our hundreds would be 2. And our last one would be 1. And that would be this in base 5. Alrighty, this leads to the last one, which is one of my favorite methods, which is known as the slide method or the lattice method. It looks like a slide. Whee! So, in this method, we try to use boxes. So first, once again, let's look at this in the normal standard base 10 system, which is our numbers 0 through 9. What's going to happen is we're going to drop these into this lattice. For instance, 8 plus 5 is 13. Well, in the bottom one, we'll always go the 1. So we'll put the 3 here. And then in this top part will be the 10, which is 1. We'll do the same thing here. 4 plus 3 is 7. Because that's not greater than 10, we'll put the 7 here, and we'll put the 0 up here, because it would be 0, 7. 2 plus 4 is 6, and because they're not greater than 10, we'll put a 0 here. Now here comes the fun part. This is where they call it the slide. What we're going to do is look at the diagonals and slide them. This 3 has no diagonal, so it just slides on down to being a 3. Then we look at the next diagonal here, which is a 7 and 1. We slide these together and we get an 8. Then we go to the next one. Slide these two numbers together and we get a 6. And the last one, we slide all the 0 and get a 0. Well, we technically don't need a 0 in front of a number like this, so then our final answer would be 683. Let's look at that one more time in a base system of base 7. So in this case, our base system, we'd have 0, 1, 2, 3, 4, 5, and 6. So here we have 2 and 5. Well, 2 and 5 would actually give us 7, so it would be 1, 2, 3, 4, 5, 6, 7. 7 is technically a 10, so we'd have a 0 and a 1. Then we look at this part here where we have 6 and 1, which is also a 7, so it would be a 0 and a 1. Last one would be 5 and 4, which would be a 9. 9 not being possible in this system, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, which would become a 12. The 2 would go here, the 1 would go here. Now let's do the diagonals. Well, we'd have to slide. There's nothing here, so we drop down the 0. Then let's slide these two together. The 1 and the 0 becomes a 1. Slide these two together. The 2 and the 1 becomes a 3. And this 1 just slides out in front and becomes 1. So our number here would be 1,310 base 7. And I hope that kind of shows you how to work with base systems other than 10.